Good morning, and thanks everybody for. It's still morning, isn't it? Yeah, it is where I live anyway. I live out on the western United States in Spokane, Washington. I've been with Autodesk about 8 years. Prior to that, 27 years as a civil engineer and surveyor, both. I want to talk a little bit about the overall value of BIM and why today and why it's important and becoming more and more important. And you can see these drivers here. I'm going to jump through these. I got a bunch of slides, far too many to show in 10 minutes. So I would suggest you download the slide deck, which also has pretty elaborate notes on this for future reference. So I'm going to jump through this real quick, but basically these are the driving factors. Tremendous population growth, especially urbanization. Urbanization is happening at an ever-increasing rate. Economic growth, sustainability are also issues. As far as your challenges as designers and engineers and even owners, is projects getting more and more complex. All the easy stuff's already been done. When I started doing subdivisions 35 years ago, it was all flat ground, all the roads met at right angles. You just don't find that kind of stuff anymore. Companies have higher expectations as a result of this. Owners are demanding more and more for less and less, and the industry has to respond to these kinds of changes. So in a traditional civil engineering process, you're using a bunch of different data sources, and you're trying to capture that and bring them all together into one platform and then make some sense out of it. You have static 2D views of your projects based on these drawings, legacy data, legal descriptions, blah, 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 all this kind of stuff. And you'd have a single user at a time working in a silo, or you'd have a bunch of single users working in separate silos. So you can't explore multiple design concepts. And when I started, the rule of thumb, there are 2 rules of thumb when I started. Number 1 was keep it simple. Get the first design that meets the minimum specifications so you can get your permit, get paid, and move on to the next project. That's changed now. You can't optimize a project because you don't have time. You have time to go through and do one design, and that's it. And you can't respond to changes, because a change means basically going back to square one. Because when I started, it was on a drafting board with a T-square. And I didn't quite, I came in right after the Alidade and plane table. For those of you who are familiar with Alidade and plane table, it's the one that Thomas Jefferson used to do Monticello in 1795. Not long after that, I came in. So the idea about using BIM for infrastructure is it's an intelligent model-based process. And whether you want to use the term BIM or not, a lot of civil engineers, infrastructure engineers are timid in using the word BIM. I heard the term SIM used. I actually proposed that when Autodesk started adopting this. And I gave them a big spiel about this. I said, you know, we could have these SIM drawings, and you could put all these SIM drawings together into a whole SIM city. They didn't like that idea. The idea, though, is to be able to begin, get it digital, keep it digital throughout the life cycle process. Planning, designing, building, manage, and repeat, especially if you're a municipal owner or a government owner. You own it forever. If you're a subdivision developer, once the lots are sold, you're down the road. But if you're a municipal owner, it's yours for life. And during this process, as we were moving along, every time there was a handoff, the blue line down below, you lost some momentum in this. You'd do some hand sketches. You'd hand them off to an engineer. That engineer then would try to read your writing, and then try to interpret your intent in that. He'd mark it up, hand it back to you, back and forth, back and forth. I've seen some of these go through 30, 40, 50 times. Keeping it BIM, getting it digital early and keeping it digital keeps that momentum built. And I'm not sure what it is with that one, but so the transforming from the traditional way into BIM is building this data-rich model. And it becomes an extractive model because you can actually get more information out of that model than you ever put in because everything is in context. There is a context for everything. Everything has its place and a place for everything. Also, it facilitates collaboration. In fact, it almost demands collaboration. And allows you to maintain consistent data across the life cycle. And in the case of government work, municipal owners, government owners, this is perpetual. So it's important that what you leave them with is something that they can begin again when they have to expand or redo the project every 20, 30 years or whatever that is. Plus you can understand potential impacts, you can try different things out at a much lower cost than you ever could before. And because you're developing rich visual presentations throughout this process, you can engage stakeholders much, much earlier. So why now? Why is it a big deal now? This is based on the McGraw-Hill data, and it's the Smart Market Report. You see the demand moving forward to 2030 is 60 trillion. The fundability, based on current funding mechanisms, is $24 trillion. How do we close that gap? We got to work smarter, faster, better. We absolutely have to do that. So you've seen this slide in the previous presentation. I don't know who borrowed it from whom. But this is kind of the circle of life for BIM. The acceleration, the implementation of this is accelerating. And it's beginning to catch on, it's beginning to take hold. People are starting to demand this as a deliverable. This is a little slide here showing kind of a global trend in the US and Canada, 45% growth in the last 3 years. That's the US, Department of Transportation is driving this in the US. There's a number of drivers in Canada for it and globally throughout the world. So what if you're able to aggregate all this data, get it digital, keep it digital, communicate the project impacts to people easily, and evaluate multiple scenarios in the process? Using one single model to aggregate data, parcel data from an Oracle Spatial database, road data from whatever format it's in, flood data, zoning data, aerial photos, and bring it together into one single rich model, and then have a context upon which to move your design forward. So you can engineer early. You can actually start the engineering early, and as changes happen, you can react to those changes much, much quicker because everybody is collaborating into this single data repository and adding and extracting intelligence from the model. So I don't know if this video will play. It won't. As far as design, making changes without blowing the schedule out. This is a big, big thing. And in my 35-year career, this was the big thing. You know, this keeps you from having to work all-nighters, you know, the week before a project submittal is due. And as well as integrate analysis into it. I used to be the stormwater guy. Everybody else would have their crack at the project, and then when they were finally done with everything, they'd hand it to Steve and say, here, Steve, put some of that drainage stuff in here and get it out. Well, by then, I'm like boxed into these little corners. No degrees of freedom on this. Whereas if you integrate simulation and analysis into the process, then you can move ahead with the rest of the design. It kind of gives you equal footing with the rest of it, as well as produce documentation by simply extracting it from the model. And again, here's another video that probably will not play. But it's all about intelligent design. You move it in plan view, it moves in the profile view. You move it in profile view, it moves in the plan view. You move it in section view, it moves in all views. So it ties all this stuff together. It's not having to cut a whole new group of sections. I pick up the mouse, move the road, move the design. As well as what you're left with is a 3D model that you can use for automated machine guidance. You can do clash detection on it, spatial clash detection, and identify scheduling concepts, as we saw in the previous presentation. You can actually do 4 and 5D scheduling on this, time and money scheduling on this. This one here will actually play for some reason. And this is, again, showing multiple options and even running some traffic simulation on this with different design scenarios. And you're doing virtual construction, virtual modeling, virtual analysis against a model before it's real, before you cut your plan and profile sections, before you hand it to the contractor. And you can do it in collaboration with the owner and the contractor and get everybody together into the same room. So bottom line is more efficient workflows, greater predictability because you're doing analysis early and you're doing it concurrent with the design. So obviously it's going to improve your project outcomes and make more informed decision making because you're able to engage the stakeholders from the very beginning in a format that they can understand. So anyway, here's a advertising slide for Infrastructure Design Suite and Autodesk InfoWorks 360. That's kind of our hub for putting all this stuff together. Here's a slide that just basically shows different types of functionalities. And I'll leave it at that. And I only went 56 seconds over. So. Thank you very much.